I'm Carson Supola, and today I'm going to teach you about balancing chemical equations. A chemical equation is a representation of a chemical reaction. In a chemical reaction, there are a few things you must know. For example, atoms are neither created or destroyed. This is the law of conservation of matter. So when balancing an equation, you cannot take away or completely add a new atom. Here are a few other things you should know about balancing chemical equations. The left side is called the reactants, and the right side is called the products. You can also never change the subscripts when balancing chemical equations. You can only change the coefficients, as changing the subscripts would completely change the identity of the compound. And when balancing chemical equations, the goal is to set up the same amount of each atom on each side of the equation. Also, one last thing, when balancing, save oxygen and hydrogen for last. Alright, so in our first example we have hydrogen and oxygen reacting to form H2O or water. Alright, the first step when balancing is to write down how many of each element you have on each side. So for this example, we'd write down H and O for hydrogen and oxygen. We would then record how many of each element we have. For example, we have 2 hydrogen because of the subscript 2 on the H, and 2 oxygen for the subscript 2 on the O. And then on the products, we have 2 hydrogen because of the subscript 2, and 1 oxygen because it has nothing with it. Alright, so when balancing, we want each side to have the same amount of each element. So the product side has 1 less oxygen than the reactant side. So to balance it, we'll put a 2 in front of the H2O. Alright, so with the 2 there, it balances the oxygens, making there be 2 of each. But it unbalances the hydrogen because now we have 4 hydrogen, because the 2 on the subscript of the H multiplies with the 2 in front of the H2O to create 4. Alright, so now that the hydrogens are unbalanced, we're going to have to balance them. So we'll go over to the reactant side where there are less, and we'll put a 2 in front of the hydrogen. Alright, with the 2 in front of the hydrogen, we now have 4, because the subscript on the hydrogen multiplies with the 2 to create 4, which balances the entire equation. Alright, so in our second example, we have carbon dioxide and water reacting to form glucose and oxygen. Alright, the next step is to write down how many of each element we have on each side of the equation. On the reactant side, we have 1 carbon, 3 oxygen, and 2 hydrogen. On the product side, we have 6 carbon, 8 oxygen, and 12 hydrogen. Alright, since we balance oxygen and hydrogen last, we're going to balance the carbon first. Since there's less carbon on the reactant side, we're going to put a 6 in front of the carbon on the reactants to equal the amount of carbon on the product side. By doing that, we create 6 carbon, but we also change the amount of oxygen, which now changes to 13. Now that oxygen and hydrogen are the only ones left, we're going to balance hydrogen first. We're going to put a 6 in front of the hydrogen on the reactant side. With the 6 there, we now have 12 hydrogen, but we also have 18 oxygen now on the reactant side. Alright, so now we have to balance the oxygen on the product side. So we're going to add a 6 to the oxygen to balance it. And with the 6 there, we now have 18 oxygen balancing the entire equation. Alright, so in this equation we have iron trichloride and ammonium hydroxide reacting to form iron 3 hydroxide and ammonium chloride. Alright, so on the reactant side we have 1 iron, 3 chloride, 1 nitrogen, 5 hydrogen, and 1 oxygen. And on the product side we have 1 iron, 1 chloride, 1 nitrogen, 7 hydrogen, and 3 oxygen. Alright, so the first thing we're going to want to do is balance the chlorides. So since there's less on the product side, we're going to put a 3 next to where the chlorides are. Alright, with the 3 there, we now have 3 chlorides, but we also have now 3 nitrogen and 15 hydrogen on the product side. Alright, so the next one we're going to balance is the nitrogens. Since we have less on the reactant side, we're going to put a 3 there, so it'll balance out with the amount on the product side. Alright, with the 3 there, we now have 3 nitrogen, 15 hydrogen, and 3 oxygen on the reactant side, which now makes the entire equation balanced. Alright, so in our last example we have aluminum carbonate, phosphoric acid reacting to form aluminum phosphate, carbon dioxide, and water. Alright, so in this equation we have on the reactant side 2 aluminum, 3 carbon, 13 oxygen, 3 hydrogen and 1 phosphorus. And on the product side, we have 1 aluminum, 1 carbon, 7 oxygen, 2 hydrogen, and 1 phosphorus. So the first thing we're going to do is going to be to balance the aluminum. Since we have less on the product side, we're going to put a 2 next to the aluminum on that side. With the 2 there, we now have 2 aluminum, but we also have 11 oxygen and 2 phosphorus now on the product side. Next we're going to balance the carbon. Since there's less on the product side, we're going to put a 3 next to the carbon on that side, so it'll be the same amount as the carbon on the reactant side. With the 3 there, we now have 3 carbon, which is what we wanted, but we also have 15 oxygen now on the product side. And since we balance oxygen and hydrogen last, we're now going to balance the phosphorus. Since there's less on the reactant side, we're going to balance it on that side. So we're going to put a 2 next to the phosphorus on the reactant, so it'll equal the same amount on the product side. And with that 2 there, we now have 2 phosphorus, which is what we wanted, but we also have 17 oxygen and 6 hydrogen now on the reactant side. So we're now going to balance the hydrogen. Since there's less on the product side, we're going to go over there. We're going to put a 3 next to the hydrogen on the product side, so it'll equal the same amount on the reactant side. And with that 3 there, we now have 6 hydrogen, which is what we wanted, and that's equal. And we also have the 17 oxygen, which is the same on both sides. So this equation is now completely balanced.